We've covered how to encode memories well. Now, what happens to a memory after it's formed? And how do we pull it back out? Storage and retrieval turn out to be active, dynamic processes, not the filing and fetching we imagine. First, storage and the biology underneath it. A newly formed memory isn't permanent right away. It has to stabilize through a process called consolidation, which strengthens and integrates the memory over time, especially during sleep, which is exactly why a good night's rest after studying helps the material stick, and why all-nighters sabotage the very consolidation you need. At the cellular level, memory formation involves long-term potentiation. When two neurons fire together repeatedly, the connection between them strengthens, making future communication easier. This is widely considered the physical basis of memory, the brain literally rewiring itself, neuron by neuron, exactly the plasticity we discussed in the brain chapter. Hebb's famous summary is that neurons that fire together, wire together. Now retrieval, and here's a liberating insight. A great deal of forgetting is not loss, but retrieval failure. The memory is still there, you just can't find the path to it. That tip of the tongue feeling, knowing you know something but being unable to produce it, is the proof. So how do we improve retrieval? Through cues. Retrieval cues are the prompts that lead you back to a stored memory, and the more you encoded, the more cues you have. A central principle here is encoding specificity. You remember best when the conditions at retrieval match the conditions at encoding. This produces two striking effects. Context-dependent memory means you recall better in the same environment where you learned. Information studied in one room comes back more easily in that room. State-dependent memory means your internal state matters too. What you learn in a particular mood or state tends to come back more easily in that same state. The most powerful retrieval finding of all is the testing effect, sometimes called retrieval practice. The act of pulling information out of memory, actually testing yourself, strengthens the memory far more than studying the same material again. This flips the usual study strategy on its head. Don't just reread your notes, quiz yourself. Every time you successfully retrieve something, you make it easier to retrieve next time. So storage is an active rewiring, and retrieval is a cue-driven reconstruction that you can strengthen through practice. But that word reconstruction is a warning as much as a description, because when the brain rebuilds a memory, it can rebuild it wrong. The unsettling truth about how memory fails and distorts is where we close this chapter.